Hello, and thank you all for joining me in this tweet-friendly presentation about the vertical distribution of North Atlantic right whales in the Gulf of St. Lawrence. I'd like to thank my co-authors for their contributions. So an introduction to the project. Obviously, we all know that the distribution of right whales has shifted over the last 10 years from the Cape Cod area and the Bay of Fundy more into the Gulf of St. Lawrence. And associated with this has been a renewed decline in the population. So one of the key questions is, how does this change influence the overlap and interactions with their main threats, notably shipping with strikes, fisheries entanglement, and obviously noise, primarily from shipping as well. So behavior is a key part of that, and we know that in the Cape Cod Bay, the right whales feed at the surface, and yet in the Bay of Fundy, they're actually known to feed at the bottom. So the question is, what are they doing in the Gulf, and how does that affect their overlap with these human threats? So the objectives of this work was to deploy equipment on the animals to explore their use of the water column and figure out where they were feeding, in particular, to look at that exposure of the animals to human threats in the Gulf of St. Lawrence. Methods we use, well, I mentioned we use tags. These were D-tags that combine hydrophones with three-dimensional movement sensors, neatly packaged with a VHF antenna for tracking and recovery, and all deployed using suction cups. And we deployed these from the Coriolis that got us out to the Shediac Valley and other areas where the whales were, where we put a Zodiac in the water so that we could put the tags on the animal using poles. And as I said, we had to track the animals and recover the tags using the VHF signals. Unfortunately, there were some logistics challenges, so we only managed to get 5 tags out over 2 years. And one of those, the whale rather inconveniently went straight into a sag and knocked the tag off. So we have here 4 data sets as long as nearly 5 hours. The results nonetheless? Well, we broke the different elements of the dive profile down into sort of service time, descent, bottom flat periods, and ascent periods. And for this animal that was, the tag was deployed while it was around about 80 meters of water, we define the surface as being 5 meters or less. Shallow dive, so any dive within 5 to 15 meters of the surface, was classified as shallow, and that's roughly the length of a right whale, which is why we picked that. Anything within 15 meters of the bottom, so for this animal, 65 meters or more, was considered a dive to the bottom, and anything between was a dive to the midwater. Note, when we break this down into time spent in the different areas, we also roll the transit time to the bottom dives into the midwater because it's time they spend mostly in that area. So here are the times, here are the results. A lot of information here, but the take-home message here in the first red line is that the time spent at the surface or in the shallow dives is up to 74%, depending on the right whale. And the time spent at the bottom, in the bottom phase of those bottom dives, is up to 60%. A lot of variation between the individuals, probably down to the behavioral mode at the time. But either way, it's a lot at the top and the bottom. Now, dive types in the literature: V-shaped dives are associated with travel, U often foraging, parabolic dives have been associated with sleeping, and the uneven dives there are assortment, often associated with some sort of interrupted dive or other activity. So the question is our observed behavior consistent with that type? So let's look at the 3D movement data we have from the tags, in this case with a U-shaped dive. Specifically, we're looking at pitch. And that's the to and fro of the animal. It's filtered just so that we're looking at pretty much fluke-only changes. Here you can see a orientation away from the surface here. And then there's a correction at the bottom as the animal levels out again to go into the bottom phase. Fluking dominates the display here in the sinusoidal signal, and occasionally you can see hydrofluking where the amplitude is greater. Once again, there's a little bit of a sharp movement and a correction as the animal goes to and reaches the surface. And note these 2 very brief gliding periods, one in the descent and one in the ascent. That's consistent with foraging, and we have additional evidence of that from Kevin Soroshan and co, who were trawling for plankton while we were doing these tagging, and noticed that there was a lot of callousness at the bottom for this area at that time. Parabolic dives have been seen to be consistent with sleeping in other species, and here you can see a very low energy fluking gliding throughout the entire dive except that brief period at the start, and maybe a small correction at the end as the animal returns to the surface. And this pattern is consistent from one dive to the next, and this stereotyped signal at a stereotyped depth, all low energy, is consistent with what's been seen for sleeping or at least resting previously. So it looks like our dives are roughly in line with the assessment in the literature previously. So where are the animals doing these dives? Well, 57% of those shallow dives are the parabolic ones. 58% of the dives to the midwater are these odd-shaped dives. A good proportion of the remaining ones are V-shaped dives. Note again, when we talk about time spent, I roll in the transit time to the bottom dives into the midwater area. 80% of the dives within 15 meters of the bottom were the U-shaped dives. And that merits a little bit of additional exploration here. So returning to the 3D movement data, in this case, pitch, roll, and yaw. Now the pitch on the tags is recorded from positive 90 to minus 90 degrees. And the roll on the yaw is 180 degrees either side of vertical or north, depending on the axis. Unfortunately, as an animal approaches 90 degrees, the roll and the yaw axis get intermixed and they're no longer in line with the activity in those directions. So it's really hard to untangle that. The mathematics breaks down and we don't get very much about roll and yaw when the animal's vertical. And that goes for vertical up or vertical down. And that's a problem for us because on the descents, the animal was reached near vertical down in the water column in the majority of the dives. Despite that, at the beginning and end, you still get a little bit of data where you can tease out roll, and it looks to be that the animal's staying pretty much upright. Although on one occasion we did see a roll to the point where the animal was pretty much upside down. Along the bottom, the animal remains fairly consistently flat and fairly consistently vertical. On the ascent, again, very close to being vertically straight up. What we can tell, mostly vertical. However, on one occasion, we did see an animal that began a roll to upside down at the very end of the dive and finished it as it started ascending. And this may be an explanation for why occasionally you see animals with mud on their heads in the Bay of Fundy. Yaw, over the entire course of the dive from the beginning to the end, the animals were generally fairly consistent in a straight line, maybe a few little weaves here and there. But there were a good few observations of animals that completed complete circuits, such as 0 degrees, all the way round to 0 degrees again. Some even managed that twice in a dive, and that may indicate that they are on a particularly dense patch of prey. Because the animals are approaching vertical, we can say a little bit about their speed, and that means they were going around about 2 meters per second, or possibly a little faster, on both their ascent and descent. So a summary of all this? Well, in short, animals spend around about 82% of the time within 15 meters of either the surface or the bottom. 32% of their time within 15 meters of the bottom was predominantly in this high activity U-shaped dives. Now, they are consistent with foraging, and this all has a serious implication for fisheries, containing bottom lines and derelict gear in particular. The animals are breathing, engaging in social activity, and also potentially sleep near the surface, spending 50% of their time in these low activity behaviors, with the exception of SAGs. This is a serious concern for shipping, especially in the subsurface, where animals are no longer visible but can still be struck, and their attention would often be elsewhere in these behaviors. There's also a concern for these end lines at spaghetti if there's a lot of loose rope at the surface. Midwater represents a very small fraction of both the dives and the time. Most of that is in transit to and from the bottom. But those U-shaped dives are actually fairly consistent from one to the next in these near vertical ascents and descents at around about 2 meters per second, maybe a little more. There's very little, if any, rolling during the bottom fillets, which is a little surprise to me. And the dives are often fairly linear, although these circular motions do occur. The implications for fisheries, I really don't know, but I would very much enjoy talking to you about that. So although this was only a pilot and we only got 5 tags deployed all in the daytime and more data is clearly needed, it's clear that these kinds of behavioral data about the animal's activity and use of the water column can actually take the risk assessment models a little further than just looking at co-occurrence and overlap and exposure alone, to actually beginning to tease out the mechanics involved in whether or not an animal is going to be entangled or not. Thanks to everyone for their assistance with deploying the tags and the logistics of all the cruises. And thanks to you all for listening. And I'll take any questions.